Okay, in this video, we're going to look at evaluating logarithms here by using a calculator. Now, before we get started with this video, let's kind of take a look back at what we've done with evaluating logs without a calculator. For instance, we've evaluated something to this effect. If we have, say, log base 2 of 16, then we can evaluate this actually without a calculator. So our thought process should be that 2 raised to what power can give me 16? And we can look on our cheat sheet here and see that 2 to the 4th would be 16. So the answer there would just be 4. Now, what we need a calculator for, however, though, is for logarithms that we can evaluate. So, for instance, here, let's change this one to log base 2 of 15. And let's see if we can figure this one out. Okay, so we're going to ask ourselves sort of that same question, except for it's with 15. 2 raised to what power would be 15? Well, 2 to the 4th power is 16, and 2 to the 3rd power is 8. So we know it's going to be somewhere in between 2 to the 3rd power and 2 to the 4th power. Okay, so my answer is going to be somewhere in between 3 and 4, more likely closer to 4, because 15 is certainly closer to 16 than it is 8. So the idea, though, is we really don't know the exact answer. And what we're going to look at is a formula that we can use here and using the calculator to do this. So let's look at the formula here that we're talking about. And the formula that we're going to use is called the change of base formula. And so what we're going to look at doing is changing the base of the logarithm so that we can use the calculator to do it. Now, let's take a look on the calculator here. Notice you have a log button here by the number 7. So I can hit log, and now that's the common log. And so we should remember here the common log has a base of 10. So for instance, if I push this one in, the log of 100, now we should be able to evaluate this one without a calculator. I'm doing this one because we can actually tell what the answer was. 10 raised to what power would be 100? Well, 10 squared would be 100. So the log of 100 is 2. Now, another logarithm that you have on your calculator is the natural log. Okay, so it's over there, it's down there by 4, so you can just hit the natural log button if we wanted to use a natural log of something. So that would be, e raised to some power is what? And if you notice above natural log here, you have e raised to a power. Okay, so we've talked about this. The natural log of e to the 3rd, e raised to what power is e to the 3rd? Well, to the 3rd power. So the answer is going to be 3. Okay, now let's look how the change of base formula can work with my calculator. So the change of base formula says this. If I have log base b of some value a, what I'm going to do is change the base of that logarithm so that it's either a natural log or a common log. Most people just use a common log here. So this can be equal to the common log of a divided by the log of b. Okay, and there again, what we're using now is log base 10s. We're changing the base from b to bases of 10 because the base 10 log, or the common log, is on my calculator. So this can also be done with natural logs. Okay, it really doesn't matter. I'm going to come out with the same thing either way. So another way to do this would be to say the natural log of a over the natural log of b. Okay, and that will give me the same result. All right, most people kind of stick with this one because normally we use common logs in Algebra 2 more so than natural logs. A lot of times in college, you'll use this one more. For some reason, colleges kind of like to use natural logs more so than common logs. Now, let's look at some examples of this. And we're going to use our calculator to evaluate them. In fact, let's do the one that we just did earlier. Log base 2 of 15. So recall we said this would be somewhere in between 3 and 4. So now the base is 2 and then the logarithm is 15. So I can write this according to my formula as the log of 15 over the log of 2. And notice that we're changing the base to a common logarithm that have the understood base of 10. So now I can push it in my calculator. And so recall, this should be somewhere in between 3 and 4, really, really close to 4. I'm going to round it probably to about 2 decimal places or whatever the directions say. So let me punch in here. Log of 15, and I've got to close that parenthesis, divided by the log of 2. Okay, and sure enough, that's really close to 4 here. So if we round it to the hundredths place, this would be about 3.91. And again, if we wanted to check this, go back to the logarithm. So according to this, 2 raised to that power should equal 15. So watch how I can check this. 2 raised to, now I'm going to recall the answer by hitting second and then the negative sign at the bottom, and then this should give me 15. Okay, now there again, we could have done this with natural logs just as easily. So we could say this again would be the natural log of 15 divided by the natural log of 2. So let's see if the calculator gives me the same result here. It should. Okay, and we also get about 3.91. Okay, let's look at one more example and we'll close this one out. So again, we're looking at logarithms that we have to really have a calculator to evaluate. So let's say we have the log of base 5 of 103 equals. Okay, now let's try it without a calculator first. So let's think 5 raised to what power would be 103? Let's see. 5 squared is 25, and 5 cubed, not 53, is 125. So we know the answer is going to be somewhere in between 2 and 3, but we don't know exactly. So let's use our change of base formula. Let's change the base to a common log since we have that on the calculator. So this would just be equal to the log of 103 divided by the log of 5. Of course, you could use natural logs instead of common logs. I'm not going to use natural logs this time. Just do it once. So log of 103. Notice I'm closing that parenthesis. Really important that you close the parentheses there. All right, divided by log of 5, and sure enough, that's somewhere in between 2 and 3. That's about 2.88. Okay, so what we really have here is that 5 raised to the 2.88 power is about 103.